Devontae Walters. I am a facilitator for the FLIP program, Families Learning and Play. I am a PlayASEAN board member and the Director of Education for Fusion Early Learning. And what I'm going to do with you today is go over the items and the experiments that you can conduct with these said items found in your Science Night kit. So real quick, we'll go over the individual bags and items for each experiment that you can conduct. Here to my right, we have the bits and pieces that you'll use to create your own satellite. As you can see, you have several different foam pieces. Okay, small piece of PVC tubing, satellite accessory, an alligator clip or a black plastic clip, a few rubber bands, and golf tees. Okay, and I've also set aside a few tinker items. Okay, an instruction sheet says you can add items from home to create your own individual and unique satellite. So I have found some tinker bits that I'm going to add onto my satellite. Right. For our balloon rocket, you have straw, pieces of straw, some yarn or string, about 6 to 8 feet in length, a balloon, and as itemized, one item that you will not have or supplied is tape. You will need some tape to adhere the straw to your balloon. Here we have the items you'll need for the chemical reaction experiment. A balloon, a little cup filled with some glitter and baking soda, your bottle, and another item that's not included in the kit is vinegar. Just your basic distilled white vinegar. Right. And lastly, to my left here, you'll need the bottle for this as well. Okay. And items that are not supplied with the kit are some pebbles or small stones and rocks. Okay. You can also gather leaves or grass. Okay. A spoon. Okay. A coffee filter. Some cotton balls. And a rubber band. Okay. In your science kit, you also find bookmarks, temporary tattoos, stickers, some other fun and cool items to just enjoy and play with your children. There's plenty of things in there. There's other information and things that you can do to further your experiments and exploration of science and space. So what we'll do is we'll come back and we'll conduct our first experiment using the items that you see here. All right, welcome back again. We're going to conduct our next experiment. For this, you'll need to create your own satellite using the foam pieces and bits that you can find in the kit. I also added some little plastic tinker bits and pieces for myself to create a little individual, unique satellite. You can add anything that you have at home, clothespins, sticks, anything to make your satellite yours. But this is how I built mine. To really conduct this experiment, you need to go outside because we've got to use these golf tees and these rubber bands to create a platform so we can conduct a shake test. We'll see you outside. All right, we are outside now. As you can see, I've placed my golf tees into the soil here. I apologize for the ambient noise, but rockets are loud as it is, so this is okay. But I've created my platform here. So I've anchored my tees into the ground, and you can see I attached kind of control bands, okay? And the way I did that is I put my first band on, and I laced the second through the middle, okay? And then I unattached these two ends so I could feed them through both of these bands here, reattach them. So now that these are in the middle, these will allow me to tug and pull on the platform itself when our satellite is placed upon it to give it the shake test. So that's what I'm gonna do right now. I'm gonna place my satellite that I built on here, and I actually had to re-engineer it from what we saw inside because it did not survive the initial placement, the balance side of things. But having re-engineered my satellite, all right, is more balanced now. So far, we were surviving the day here. I'm gonna grab one of those control bands and I'm gonna shake our platform a little bit. You can use both hands to shake back and forth. All right, I'm gonna just use the one so I can hold our camera here. But I'm gonna give myself 10 seconds. This guy survived 10 seconds of shaking before I declare it a successful test, right? Now, if it fails, well, I need to look at re-engineering my satellite. It could be off balance on one side, too much weight, right? That's why this test is important for satellites and rockets and things that rocket scientists create or the engineers create to make sure that the structures are sound and it'll survive the rigors of space. So let's grab one of our bands here, and you guys count with me. 1, 2, 3. Oh no, look at that. 3. I got to 3. Well, perhaps your satellite will be more successful than mine, but if not, you do what I did. Just go back, re-engineer, recreate your satellite, and try it again. So that's the shake test. So hopefully your shake test and balance test will be more successful than mine. All right, welcome back. So what we have here is we have the chemical reaction, the balloon inflation experiment. Just a few items. It has the balloon, our bottle with some vinegar. You can see I filled about 1/3 of it up, a spoon, and our baking soda / glitter mixture. Okay. What we're gonna do first is we'll first spoon some of this mixture into the balloon, right? We're gonna fill the bulbous end. We wanna leave the neck clear and empty. We need that to have some flexibility so we can conduct the experiment correctly. All right. Now be aware that it can be a little messy. You will spill some of this mixture onto a surface table or wherever you are, the counter space, wherever you're working on it. So just kind of gently spoon some in there so you can hold it over. Let it work down into the bulbous side of it. And you do want to get a nice good amount in here to help us fully drive the reaction we're looking for. Okay. Now, if any of you have ever done an experiment in school like a made your own volcano, right? You kind of know what the reaction we're looking for here or what's going to happen, okay? But your children might not, so. As you fill this up, you can count how many spoonfuls we use, or spoon tips in my case. All right. Let's do a couple more. All right. You don't have to use the full amount. Maybe you want to conduct this experiment again for a friend or a sibling, a neighbor, mom or dad, anyone who might have missed it. They can participate with you in science. Science is fun. All right, so we're gonna stop there and got about that much done. The next step, very important. We don't want to spill any of this into our vinegar yet. Okay, all right, that will spoil the surprise. So we're going to firmly attach the opening, the mouth of the balloon over the bottle top without spilling in the contents. If you want to, you can always add rubber band to make sure it stays in place. Okay. And before you turn over your bottle, or even your balloon, make a prediction. What do you think is going to happen when we turn things over? Okay. You will get a reaction for sure, right? But what will happen? Okay. All right. So make your prediction. Okay. And we're gonna give ourselves a countdown. We're gonna count backwards from 10 to 1. We're gonna turn over that balloon, dumping the contents of the balloon into the vinegar, and then we're gonna watch what happens. You guys ready? Here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Whoa, check that out. Look at that. Make sure you hold that balloon on tight. There's a violent reaction happening right here, okay? You can see our contents inside are bubbling, they're frothing, they're foaming, okay? And what happened with the balloon? Yeah, the balloon inflated. So you may have mixed baking soda with vinegar before and seen the bubbling action, but the part you can't see is this, the gas that's released, okay? So when baking soda and vinegar mix, they produce carbon dioxide, right? And carbon dioxide is an invisible gas. You can wave your hands to the air, there's gonna be some carbon dioxide there, right? But with a balloon, we get to see it, see in quotes, okay? Right? Pretty cool. And because we mixed in a glitter, there's now a particulate, a contaminant in our liquid here, which we'll need for a later experiment. Okay. So pretty cool, right? So what will happen is vinegar is acidic on the pH scale, it's acetic acid, right? And baking soda is a base, so on the alkaline side. And when the two meet, they exchange a proton, okay? And that proton is borrowed from the vinegar, and it produces this reaction, creates carbon dioxide that is released from the baking soda, and neutralizes the acidity. And our vinegar is partly water now. Okay? Can't tell, but some of this is water, some of this is still vinegar. Right? And what we want to do is we want to wash out some of this glitter that bubbled up and filled our balloon. And then I'm going to remove the balloon, and we'll make a prediction what will happen when I let go. Okay? So I'm just going to dump this in here a little bit. I want to swirl it around, get some of that glitter back into our bottle. So we're going to use that for an experiment. All right. So I'm going to pinch the neck of our balloon. Okay, we want to trap that gas in there as best we can. Slowly remove it from the neck of the bottle, or the top here. Okay. All right. So holding my hand now. When I let go of this neck of the balloon here, what will happen? Yeah, it's going to flutter about, right? That's an example of actually propulsion, which we'll also cover in a later experiment, but the elasticity of the balloon is going to push or squeeze the gases inside out through the opening, giving it to, causing it to propel itself forward, and because it's in a regular opening, it's going to flap back and forth, and the balloon will change directions. So, ready? Give yourself something to count down. 5, 4, 3, 2. There you go. Welcome back. As you can see, we've kept the vinegar and glitter from our previous experiment in our bottle. Okay. Because we're going to conduct an experiment or an activity having to do with filtration, okay? So what I have here is, I have a bottle, I have a rubber band, coffee filter, some cotton balls, and some pebbles I collected from outside. Small pebbles, hopefully they will fit into our bottle. You want to add these to your bottle, just one at a time, obviously. We're going to fill them in. Okay. There's going to be some volume remaining in our bottle, so they can add other things from nature, twigs, grass, leaves. And the idea behind this is to show you children how water can be filtered naturally. Uh-oh, that rock doesn't want to go in. There we go. When it falls to earth, especially right now, we have some rainfall going on. Okay. So we'll fill in our rocks in, dump them in. Rocks kind of first line of the fence, if you will. Leaves and grass. And then you have soil, sand, silicate, all those things work to filter out contaminants. So now we have our rocks in the bottom, okay? There's still some falling left. I could add more things in, but I'm just gonna use our cotton balls to plug up this bottle top, right? Hopefully I don't drop any into the vinegar here. So it looks like I'm just gonna use the one, okay? I just have the one there plugged at the end, right? And I have our coffee filter, which I folded into quarters so I can easily attach it to the top and secure with a rubber band. We don't want it to move. Right. Yeah. Okay. So get this on here. And once you have rubber band secured, have the rubber band around your filter, we need to make some predictions, okay? I have a bowl here, I have a clear bowl so you guys can see what will happen. But we need to predict what's going to happen. What is going to happen when I tip over our bottle and into our bowl here? What will happen to the glitter? What will happen to the contents of it? Make a prediction, and then let's find out. Will our glitter be filtered out? So we're gonna tip it slowly because I have rocks in here. We don't want to overwhelm the integrity of our filter and our rubber band set up here with the weight. So I'm just going to tip it over slowly. Okay. Okay. All right. Okay. Now, can't see it yet, but our cotton ball is getting wet. I can feel it. Pretty soon we'll start getting a drip drip action. I'm just gonna squeeze the bottle there. All right, so I gave the bottle a squeeze. You see that our vinegar is slowly coming out, but it's not carrying any of that glitter, right? So in nature, we would find the same thing happening with rainfall and water. You know, it can pick up contaminants, dirt and other minerals, right? There may be things in there we don't want in our drinking water, okay? And so rocks act as the first line of defense, if you will, okay? And then you have grass and soil and leaves, like I said it before. And as the rainwater introduces itself back into our drinking system, a lot of those contaminants are filtered out, okay? Leaving behind clear drinking water. Yeah. So it's contaminant free. Pretty simple. We're just checking out the filtration here. Now, if you want to do this again, you can always cut the bottom of the bottle off, add your layers of things, sand, silicate. You can run this experiment many, many times. You can use different things, or you can keep the integrity of your bottle together and do what I did. So, I happen to squeeze the bottle to force some of that liquid out. We have the bottle top or the bottle bottom cut off, then the volume would fill with air, and that would help the contents move out through the filters we've set in place here. But there we go. A very successful experiment and activity. All right. We'll set that aside. We're going to come back with our next activity. Stay tuned. Welcome back. We're going to conduct our next experiment. This is with the creating a balloon rocket. You need string, tape, which is not supplied in your kit, one of your balloons, 2 pieces of straw, right? And a stable platform like a chair leg or a doorknob, a handle, something that you can tie that string onto firmly and securely, okay? As you can see, I've already inflated my balloon, and I've attached both straw pieces to the balloon, okay? So here, I'll bring it a little closer for you. The reason why I've attached both, it gives me a little bit more of a controlled and stable, we'll call it connection with the string here. And I've attached one piece closer to the mouth or the neck of the balloon, and one a little further along the body. And hopefully this will allow it to go a little straighter. So just as we did with the inflation experiment, we have gas inside, okay? The gas in here is just for my own lungs. So it's oxygen, carbon dioxide, nitrogen, the air that we breathe here. I've expelled it, okay? And of course the force of my lungs has caused the balloon to inflate, right? And I'm pinching the neck of it shut very tightly up to my fingers here, okay? I want to keep this gas from escaping, right? But what we're looking for is, previously I let the balloon go and it just went all over the place. What we're trying to do is see this in a more controlled fashion. Hopefully it'll fly straight along our string. So I've run the string through the straws, I inflated the balloon, and then I used the tape to attach the straws to the balloon firmly. As the balloon deflates, they may or may not remain attached, we'll see. But we'll do that, give myself a lot of room here. The string in your kit is very long. So potentially you could have a balloon rocket race with someone, a friend, a sibling, a parent. You see, when you inflate it, you see whose lungs are more powerful, right? You can measure the distance that travels along the string. A lot of things you can do with your kit. One important thing you want to do is you want to give yourself a good amount of room, but you also want to make sure that the string is taut. I mean tight, okay? So I'm going to do my countdown. 5, 4, 3, 2, 1. All right. So as you can see, initially it took a little bit of time to get going along the string, right? You need a moment to build up, right? Expel enough of the gas to fly straight. But our experiment was a success. And you see, a balloon did come unattached, right? You can experiment with how much you inflate it and see how far it goes again. You can try different types of balloons. You can do a lot of different things with this. But this is our propulsion experiment, right? And explaining propulsion, the elasticity of the balloon caused it to contract, okay? And that contraction is pushing the gas inside through the most convenient available opening, which is through the neck, the opening of the balloon here, right? And that gas expelling pushed my balloon along the string. It took a moment to get going, but as it became a little more streamlined, it did move forward, right? Propelled, right? If it was not attached to the string, the fluttering action at the mouth of the balloon, the opening here, would cause it to fly a little haphazardly, right? And right at the very end, if it was not attached, the elasticity of the balloon would be so much greater than the air that's inside. It would force it to expel quickly. So if you ever inflate the balloon, let it fly around, at the very end before it's fully deflated, it will fly a little quicker, right? But that's what we did here. We just took a quick look at, a rocket. Rocket science is actually very complex. Or building a rocket is very complex, but the science behind it kind of simply explained. So this was our balloon rocket. We examined propulsion. Try it again.